Greetings to all. Myself Arul Soumya, working as an assistant professor in Department of Information Technology. So here I'm going to share about the cloud computing virtualization. That is memory virtualization. So memory virtualization means unlocking the power of shared memory. So transforming how we think about RAM allocation and utilization in modern computing environments. So what is memory virtualization? So memory virtualization in the sense the abstraction layer RAM from individual server into a pooled virtual memory resource accessible across the network. And dynamic allocation. It enables the multiple systems to share and dynamically allocate the memory beyond the individual physical hardware limits and not a traditional virtual memory. So different from virtual memory, that is disk-based extension. So why memory virtualization matters? The first one is bottleneck elimination and performance optimization and advanced computing support. So bottleneck elimination in the sense it overcomes the physical RAM bottlenecks in data centers and cloud environments where memory demands exceed individual server capacity. So performance optimization in the sense it allows the application to access a large flexible memory pool for dramatically better performance and it reduces the latency. So advanced computing support in the sense it supports the high-speed caching, messaging layers and shared memory architecture for both CPUs and GPUs. So how memory virtualization works? So here the diagram shows how the memory virtualization works. So first step is memory aggregation. The second one is address mapping. Third one is seamless access. So memory aggregation in the sense a software layer aggregates the RAM from multiple servers into a unified pool. So address mapping in the sense it maps the virtual memory address to physical memory across the cluster transparently and handle all routing automatically. So seamless access in the sense the application or operating system access pooled memory as it would work if it were worked in local hardware dramatically boosting the utilization efficiency. The next one is integration approach. Here the application level integration and OS level integration, there are two types. So in application level integration, it connects directly to the memory pool via specialized APIs. Here direct API integration, custom memory management and application specific operations are packaged. So in OS level integration, the operating system transparently used the pooled memory as an extended page cache resources. So it has transparent to application, system-wide memory extension, and automatic management. So here the real-world platforms and examples. So real-world platform in the sense it has scale MP with SBSMP. Next one is enterprise Java solution and distributed caching. So what are the key benefits? Key benefits in the sense it has resource optimization, dynamic scaling and enhanced performance. So resource optimization in the sense it improves the memory utilization and reduces the hardware cost by intelligently pooling and sharing the resources across the infrastructure. So next one is dynamic scaling. It allocates or deallocates the memory based on real-time workload demands without the hardware changes or system downtime. So enhanced performance in the sense it dramatically improves the application responsive and overall system efficiency in cloud and data center environments. The next one is implementation challenges. Implementation challenges in the sense it has three requirements, namely network requirements, complex management, and security and isolation. So network requirements in the sense it requires ultra high speed, low latency network connections between memory contributors to maintain the performance. So complex management in the sense it manages the large distributed memory pool. The security and isolations are protected of shared memory data while maintaining the multi-tenant security. So here is the future of memory utilization. So the first one is growing importance. It increasingly vital as data center scales and workloads demand the greater memory agility and resource flexibility. The second one is hardware acceleration. Hardware acceleration in the sense it advances in hardware assisted and virtualization technologies and it reduces the overhead and dramatically improves the access speed. So next one is seamless integration. It paves the way for truly seamless and efficient and secure memory sharing at massive scale across the global infrastructure. Thank you.